Yes. Sorry for that. Yeah, I think you got it right. What is job? With the preceding number, you divide with the preceding number, you get the common difference. And to get the nth term of the geometric sequence, this is the formula. If you see, let's see this sum. Given that 16, 18, 4 are the first three terms of the geometric sequence, and find the fifth term of the sequence. How to find it? This is the formula. A5 is equal to A1. What is the first term? 16 into 16 into R power n minus 1. How you get R? Can anyone tell quickly? Hello? The common difference. Hello?
Sir, R is the ratio. R is the ratio.
What ratio of what numbers, ma? Second number and the first number, right? 8 by 16. You will get 1 by 2. Yeah, 4 by 8 on the common ratio. That is 1 by 2 whole power 5 minus 1. Yeah, thank you. SBN. Thank you so much. Right, this is the series, and you will see this. Now, geometric mean in the different models are just go through it. Okay, this is about the AP and this. Now let's go into the different thing, matrix or matrices. Okay, let's fix this. What is there? What is matrix? And Kelly, who developed all the aspects of the matrices in 2019. Why we need to understand the history means from which year this concept is developed. It is not a new thing. People are started thinking about or learning about, or they found about this matrix in past years on. And these year people, and we are in the, which century we are in now? Hello?
21st.
21st century. 19th century people have developed this, and we people are having trouble to understand those concepts, right? Yeah, thank you. Right, we people are having trouble. See, those minds and our minds are, our thinking is far better than them. I mean to say far better means in the sense like we have a lot of things to learn, but they have very limited things. But in 1850s only, they started developing this, and they gave this, and now we are breaking our heads to understand their concepts, which they are developing. Just go through this. There is something. Yeah, this is the matrix. We know this. R denotes the rows. You remember that rows means the horizontal one. Columns means the vertical one. Remember that. Okay, there is always the confusion in the matrix. R is the row and column. Right. Okay, this is the sample of the matrix. And matrix equality. To understand matrix, we need to understand matrix equality. Each matrix has the same number of rows. We know that. This is the thing, equality, same number of rows. And each matrix has same number of columns. And corresponding elements within each matrix are equal. Okay. Right. This is the example for this. And there are 5 elements in this. This special matrices. We need to understand this. Row matrix is this one, as I told you, the horizontal one, and the vertical one is the column matrix. The square matrix, if it is 2 by 2, 3 by 3, if the columns and rows are equal, then we call it as a square matrix. Okay, very simple. Diagonal matrix is symmetric matrix with zeros in off diagonal elements and values in the diagonal elements. So this, if you take it in diagonal, this will show. So this diagonal matrix elements that run from the upper left corner to the lower left corner. Upper left corner to the lower left corner. Next, scalar matrix. It is a diagonal matrix with equal valued elements. Right, scalar matrix is along the diagonal, equal elements are there. Along the diagonal, 6 Is my screen visible now? Yes, no?
Yes,
Yeah.
yes.
Yeah, unique matrix is this. Next, null matrix. In the matrix, if all the numbers are 0, then we call it as a null matrix. Now, here we need to understand distance matrix. Between the given number of cities can be represented as matrix. See this? A, B, C, D, M, N, O, P. Right? This is the thing. Now, assignment matrix. Assigning. Let us say there are 3 workmen are there. Or W1 workman, D1, 7 is his duty, 7th duty, 6th duty, 2nd duty, or 2 duties, 6 duties, 7. Right? Transportation. Here, we will have, I think, in the future units, we will have the transportation problems and assignment problems. There you will understand what is assignment and what is transportation problems means. Okay. Next, brand switching matrix. Brand 1, brand 1, brand 1, brand 2. The proportion of users in the population served switching of brand J of any item in a period. The brand 1, they may go for 0.8, 0.9, 0.3. Diet matrix, okay, intake F1, you take 750 proteins, F2, 800 for the B point, B protein, 800, like this. This is this kind of representation. Try to understand this. Payoff matrix. This is where we will use in the game theory. The payoff matrix we will calculate by calculating the payoffs 10 minus 10 minus 10 is equal to 20 minus 10 minus 10 is equal to minus 20. Like that, we will find out the payoffs from this matrix. Now, matrix algebra. What is matrix? 2 matrices can be added, subtracted only if they have the same dimension. What is dimension means? If it is a 2 by 2 matrix, if it is a 3 by 3 matrix, if both the matrix dimensions are same. If it is 2 by 2, then B is 2 by 2, then only we can add. If it is 3 by 2, then 3 by 2, then only both will be added. Like this, this is the thing. Because it is has, what is this matrix? Can anyone tell? 2 by 3 or 3 by 2?
3 by 2.
Very good. 3 by 2. How many columns are there? 3. How many rows are there? 2. 3 by 2. This is also 3 by 2. This is also 3 by 2. Then only we can add or subtract or do anything. See, these are easy things. That is why I'm just going fast in this. Wherever the tough things, see, C is equal to A plus B, D is equal to A minus B, you can do that. Properties of addition, A plus B is equal to B plus A. If both dimensions are same, you can do that. A plus B plus C is equal to A plus B plus C, because all the, when the, say, adding, subtracting and I don't think multiplying is there. Both will be happen when both the dimensions are same. If the dimensions are different, we can't do that. Provided if that dimensions are there, this is the thing. Cumulative property we can do, associative property we can do, additive identity property, A plus 0 is equal to A. Additive inverse property, A minus A is equal to 0. Right? Matrix subtraction also we can do this. A minus B not is equal to B minus A. This monad happen. But see, go through this, you will understand this. Easy thing to understand. Okay, how to work on this? A cannot be added because A has more columns than A. Matrix may be added or subtracted only if they have the same number of rows and same number of columns. Hence, A plus B not is equal to C. We can't do that. Scalar multiplication. Scalar multiplication is that when you multiply a matrix by a number, you multiply every element in the matrix. Like, for example, 2 into x plus y is equal to how much? 2x plus 2y. We are multiplying the 2 into x, we are multiplying 2 into y. At the same time, when you're multiplying a number with the matrix, we need to multiply the same with each and every number in the matrix. Right? 2 into 100, 2 into 200, 2 into 300, like that. 5a, 5 into this. Okay, just you will understand this. Multiplication of the matrix. How we can do that? This is this multiplication. Multiply. One second. Multiplication of the matrix product A and B defined only when the number of columns in A is equal to the number of rows in B. This is different. See, plus easily add, minus, of course, easily we can do that, but A plus A minus B not is equal to B minus A. That we need to understand. I think we know that, right? It's a common sense to understand that. Multiplication, when you're multiplying, see this. Columns in A, let us say, here let's go directly into this. How many columns are there in this quickly?
Three, sir.
Three columns. How many rows are there?
2 rows.
Correct. 3 rows, sir. Rows means rows, columns. Thank you. But anyway, thank you. Yeah. There are 3 columns, or there are 2 rows. There are 2 rows and 2 columns, right? This row will be multiplied with this column. 0 into 6 plus 1 into 8, 2 into 10, like that. See, 0 into 6, 0 into 8, 1 into 8, 28. Finally, we will get this. A, B is equal to C. If you multiply, you will get it. Okay, multiplication order is this. And now the assessment, transpose of race. This is also important. Yeah, A is the matrix with any number of n number of rows and columns. Then the resultant matrix is obtained by interchanging the rows of the columns. For example, let us say, just simply I'm going into the example. This is the matrix. What is the transpose of A? You write these column numbers as row numbers, and the second column as the row number. That is called transpose of race. Okay, you got it? Hello? Yes, no?
Yes, sir.
Yes, sir. Yes, sir.
Again,
Yes,
I'm
sir.
repeating. Yes, ma.
Yes, sir. Yes, sir.
Yeah, you understood, right? Say transpose means what? Let us say, what is transpose of A? This is the column 111, 333, 355. In the transposing, when I'm transposing this matrix, I am writing this column as row, simple 111, 333, 355. And this column 222, 344, 366, 322, 322. You got it right? Yeah.
Yes, sir.
You
Column
understand, you will understand this. Yes, ma. If it is column to row, or
Yes,
you
sir.
write like row to column, anything is fine. Say this is row 111, 222. You write it as a column.
3 by
Yes,
2
ma'am.
matrix changes 2 by 3 matrix, right?
2 by 3 to 3 by 2.
Not
No,
like
no.
that, ma.
2 by
See,
2,
don't
2 by
remember
2,
in that way. Don't remember in that way. Not 2 by
3 by
2, 3 by 2. Just leave it. First, take this column. Say in A, how you read out the numbers.
111,
What are the numbers in column?
111, 333, 555.
Very good. And if you write this column numbers as row, make it as row. And I think you may understand Telugu. నుంచున్నాయి పడుకోబెట్టండి దాన్నే ట్రాన్స్పోజ్ ఆఫ్ రేస్ అంటారు. ఇవి చూడండి ఈ 3 నుంచున్నాయి ఎట్లా ఇది ఎట్లా అడ్డంగా పడుకోబెడితే దాన్ని ట్రాన్స్పోజ్ అంటారు. సింపుల్.
Yes, sir.
Okay, sir. Thank you.
Right? Very easy to understand. Remember. Okay. I mean, in this, under those things, you will understand. Now, determinant of square matrix. Yeah. Properties of determinants. Yeah. Let us take this. We can compute the determinant according to the following formula. Determinant. How we will identify the determinant? Very simple. See this. I am going into the example directly. This diagonal A11 into A22. Is my cursor visible to everybody?
Yes, sir. Yes.
Yeah, if my PPT is there, I can use some bold cursor, but directly opening this PDF. A11 into A22 minus same this diagonal A12 into A21. If it is 3 by 3 matrix, see this A11, A22, A33 multiplication, A12, A23, A31. Right? A12, A23, A31. Okay, if you see this, you will understand clearly. This is the formula for 3 by 3 matrix. How to work on this? Go through the example, you will understand. Now, what is the determinant of matrix A? Simple. How you will identify? Mod A is equal to 1 into 1124. So this one, 1 into 1124 minus 1 into 1114, 1114 plus 1 into 1112. Like this. You multiply this and you will get this determinant of matrix A. Inverse of matrix. What is this inverse of matrix? This is also simple. A power, let us say A is there. A power minus 1 is equal to 1 by determinant of A into this one, D minus B minus C, A. How we will do means, see this, you diagonal will be changing this. D will come here, A will come down, and both the things will become minuses. Simple. Now, find out the determinant of A. 2 by 4 into minus 3 by 1. This is determinant, right? Like DETA means determinant. 3 into 1 minus 2 into 4 is equal to 5. First, you need to 2 into 4 minus 3 into 5. That is determinant of A is 5. Now, adjacent of A. What is adjacent of A? You write this 2 and 4 volta. 4 will come there, 2 will come there. And 1 will become minus 1, 3 will become minus 3. That's it. 1 by determinant of A into adjacent A. This is the answer. Simple. Inverse of the matrix. Right? These are all the parts of this. If you go into these examples, you will understand clearly. Now, representation systems of linear simultaneous equations. How we will do that? Now, actually, we will do these kind of things generally when any equation is there. We can easily represent those equations into a matrices. Okay, these matrices we can consider like this. For example, this is an equation. Okay, leave these A11, A12, leave this, just leave it. But just look at the screen. Okay, let's directly go to the example. This is good to understand. Instead of looking at these A1, confused, look at this example. 2x plus 3y is equal to 8. 3x minus y is equal to minus 2. Okay. And when we are, remember this heading, how we will represent the systems of linear simultaneous equations in a matrix. This is the point. And if you take this equation, 2x plus 3y is equal to 8. 3x minus y is equal to minus 2. This is the equation. How we will write the coefficient of this? 2, 3, 5 minus 1 and xy. Because the variables we have x and y, so we can write the variable matrix as xy. Simple. On the right side of the equality, we have the constant terms 8 and minus 2. We will write like this. This is how we will represent any equation. You got it? Hello?
Yes, sir. Yes.
Very simple. Yes, ma. Understood, right?
Yes, sir. Yes.
Yeah. See, again, I'm just please look at this equation and directly look at it. Okay, let me. Now, I think the question and answer is clear from here. There is this question. Okay. All right. Question is on the top. Let me decrease the percentage. See this? This is the question. How we will represent this equation in a matrix? Very simple. 2x, 3y is there. And I am writing 2, 3, 5 minus 1. See this? 2, 3, 5 minus 1 into xy is equal to the right side 2 constant what we have. I will write in the right side as a column. Simple. I hope everybody understand. Hello? Yes, no?
Yes, sir.
No?
Follow, sir.
Is it clear, ma? Speak bit louder. Okay, right. Okay. The same thing. You bring out these constant, coefficients of x, y, z as one matrix. And how many constant variables are there? X, y, z. You multiply this. You need to write like this, not x, y, z or x, y, z like this. You will just look at these 1 or 2 examples, you will understand. Bringing out those constants and writing out those variables is separate thing. Right side, anyway, you can write as it is. Right side constants will write as a matrix. Not a miss. Okay, where we will use the matrices, go through this, you will understand a lot of things in this. Right? Easy to understand the matrix. It's all, the basic concepts of the mathematics where we need to apply. And quantitative techniques, as I told you, even in the statistics, we will include the mathematical related part in that. That is why generally in they have a subject called business mathematics. Mathematics use business related in the business area. We will study there. Okay. Right. See, these are all the basic things only. I think in your 6th or 7th standard, you all have studied, right? Yes or no? Yes, no?
Yes, sir. Yes.
But I think you all have forgotten this.
Yes, sir.
Correct, right? Forgotten. Everybody. Okay, right. Let's go to this. This is bit derivatives, concept of the derivatives, bit tough thing, but try to understand this. Differentiation concept. Directly, I will go into the examples. All these things, it will be tough for thing to understand. Now, derivatives. In the 10th, this is a very toughest thing. Even for the intermediate also, I think in 1B and 2B, these subjects will be there. I still remember I did my intermediate MPC and I did my PSC, Mathematics, Physics and Computer Science. And after that, I did my MBA. Now I'm doing my PhD in my MBA only. But I still remember these terminologies. Okay, I'm now teaching to the business students, but I still remember this mathematics which are related to the business, which I have studied. I'm recollecting everything and I'm trying to teach to you. Okay, right. Y is equal to K, where is derivative of a constant. Then take, for instance, if Y is equal to 100, then dy by dx is equal to 0. Why? Because the derivative of a constant will always be don't ask me. Okay. If you are asking why, means you need to go to the basics. By the what we have, why you ask, I can tell why means, but it's overview of I can't tell why and this, but correct only. What I am talking is correct. Okay. All right. Derivative of a power function. Y is equal to K into exponent, where coefficient K and exponent N are constant. Then see this. D by dx. Dy by dx is equal to d by dx and K into x power N. That is equal to K into d by dx x power N. Actually, x power N derivative is x power N minus 1. N into x power N minus 1. Okay, bit confusing and tough only, but you need to by heart this. You need to by heart. What is derivative of x power N? Okay, K constant, it will become like that. Okay, x power N derivative is N into x power N minus 1. You need to by heart these things. How? We don't. For example, if y is equal to dx, what is dy by dx? That means derivative of 100x is equal to what is x derivative based on the above equation?
N into x over n minus 1.
Very good. And in other words, n into x power n minus 1. See, in x, automatically 1 will be there in the power, x 1 will be there. 1 into x power 1 minus 1. What will happen? Generally, x power 0 is equal to 1. Actually, x derivative will be 1 all the time. But for your understanding, x derivative is defaultly x power 1 will be there. As per the above formula, x power n is equal to n into x power n minus 1. Based on that, 100 into 1 power 1 into x power 1 minus 1, x power 0 is equal to 1. 100 into 1 is equal to 100. Simple. Okay, for this, this is the basic thing of the derivative. If you so we all have to break our heads. Now see this. If u is equal to x power 3 power 5, v is equal to x square, then dy by dx is equal to how much? First, we need to identify free. First, x power 3 plus 5 into d by dx into x square. This is the formula. See this. Dy by dx is equal to u into dv by dx plus v into du by dx. Based on this formula, this equation or this answer will come. Okay. Quotient of two functions. If there are two functions, u is equal to f of x, v is equal to g of x. Then dy by dx is equal to how much? This is the formula. Based on this formula, you need to apply here. U is equal to this, V is equal to this. What is U by V? Okay. And dy by dx is equal to here x plus 2 means here x plus 2 into dy by dx. If you see V means x plus 2 dy by dx into x square plus 5x into U minus again U into dv by dx. This will come and V square, V is equal to x plus 2 whole square. This is the equation. Nth power of the function also same, just function of a function. Now algorithmic functions. Now algorithmic function is also another type of functions where y is equal to log a, where u is equal to f of x. Differentiation is equal to dy by dx is equal to, remember this, 1 by u into log of e by a into d by dx of u. Okay, that means d by x derivative of u. For example, let's see the example. What is this? Y is equal to log x square whole power square. What is the derivative of y? Dy by dx is equal to, see, you consider this as x square. What is the x square? Is equal to 2 into log x into dy by dx of log x. Okay, 2 into log x square into dy by dx of log x square is equal to 1 by x square into 2x. That is equal to 1 by x into log x square. Few things will be cancelled, x will be cancelled, and this is the final answer. Let us say this is log x by x plus 1. What is the formula for this? 1 by x by x plus 1 into d by dx of this. 1 by x into, you solve this, again derivative of this, a by b, formula will come, this into this minus x by this, and finally this is the answer. Okay, exponential like this, exponent a power u, log e power a power u, then see, this is the thing. For example, y is equal to a power u, where u is equal to f of x. Then what is the differential function of x? Then dy by dx is equal to au into log e power a into u. This is the formula. Based on these formulas, we need to write these examples. Implicit functions. Okay, higher order differentiation. Again, if we have the higher order means here, let me go take you to the examples. Okay, see this. If y is equal to f of x, then determine the higher order derivatives of the function. How to do that? First, derivative of f of x is equal to dy by x is equal to d by dx of this equation. And fx cube. What is the derivative of fx cube? 3 into 5 power x into 3 minus 1. X power n, you need to follow here. And 5 into 3 will come here. 3 minus 1 x square. Again 2 into 3 into x power 2 minus 1 is equal to x power 1. X will come. 2 into x whenever the x derivative is 1, 10 into 1. And constant derivative is always 0. Y derivative is 0. We kept 0. Then f derivative of f of x is equal to, this is the answer. You do another again. For this, again do the derivative. F double derivative of f of x. Again you apply this. 2 into 15 into x power 2 minus 1. See this one. And minus 2 into x derivative is 1. 6 into 1, 6. Anyway, 10 is the constant. 10th derivative is 0. 5 into 2 into x is equal to 0. 30 into x minus 6. This is the thing. Okay, again do the third derivative, fourth derivative, and it will come. Now, where is these derivatives are applied is the question. Finding the rate of change of a quality quantity. This is the most basic derivative that helps find the instantaneous rate of the change of equality, right? And finding the equation of the tangent and normal for a curve at a point, finding the internal wherein a function has been increasing or decreasing. We need to understand whether the function is increasing or decreasing. Finding the turning point of a curve, therefore find maximum minimum values of this. Okay. And there are some real-time applications of derivatives also. Okay, go through this, you will understand. Average cost, marginal cost, also we need to apply the derivatives. See, these are very basic derivatives which you have given in the elasticity. And anybody, economics, anybody studied here? Elasticity of demand, break-even point. There also they will apply these derivatives. Next one is the optimization. How to optimize this? First derivative says, second derivative says, maxima and minima and its characteristics. These are all the theoretical part. If you go through this, you will understand this minima and maxima things. Geometric analysis. Again, basics of the geometric is there. Increasing and decreasing functions. And this is how the function is represented in that. Whether this function is increasing or whether this function is decreasing. Based on the values, you will understand that. Criteria, the necessary condition. This, if you read this, you will understand. The sufficient condition also, go through the content that you will understand this. There are different methods in finding the maximum and minima in the derivatives. Okay, the revenue, cost, and the production items, etc. These are few examples they have given. Okay, even there are some managerial applications of maximum and minimum as well. Okay. Right. Now, these are the basic mathematics that you have studied in this block 1. Block 2 is we are going into some, as I told you. Can anyone define what is statistics? Simple 3 terms I told you. Quickly. Kalyan.
Collection of data and interpretation.
Very good. Interpretation. Thank you so much, Kalyan. Thank you for your answer. Right? Analyzing the data. Sorry. Collecting the data. Analyzing the data. Now, in the research, see, this is a that we are going to study. In the general, what is business research? We will tell what is research and all this stuff. And in the data collection, what are the various ways we have to collect the data and how to measure the central tendency and what is variation and the Q-ness in the method. This is bit 7th and 8th units are problematic. 5 and 6 are theoretical units. See, whenever I say theory, you by heart each and every topic in that particular unit. Very easy. Okay, let's go into the 5th unit. I'll give some overview of this. Or shall I continue tomorrow? This block 2. Next week. Okay, all together, block 2, the 5, 6 units, I will do it on Saturday, and 7, 8 units, I will do it on Sunday.
Okay.
New and tough for few people. For few people, if you have some mathematics background, can easily grab it. Sorry, we don't have chalk and board way of explanation. But this is what. Okay, thanks so much.